everyone. Today we'll see analytical problem of single stub matching. In the previous class, we saw about what single stub matching is and what double stub matching is. When you see a single stub matching, it is used for single fixed frequency. When you have a double stub matching, it can be used for more number of frequencies. Today, in that single stub matching, we'll see an analytical problem. So the question is a 300 ohm transmission line is connected to a load impedance of 450 minus J 600 ohms. Find the position and length of the short circuited stub required to match the line using Smith chart. So here if you see in the question it is given the impedance of this connection. So whatever impedance is given, the first step that you have to do is we have to normalize that impedance so that the given value can be plotted graphically. The equation to find the normalized impedance is ZR is equal to, that is the normalized impedance is equal to the given impedance divided by the load. So we have 1.5 minus J2, that is when you see in the previous the given question is divided by that 300 ohms. So once we do that, we get the value to be 1.5 minus J2. So this 1.5 has to be taken from this real axis, that is the center axis, and this 2 has to be taken from the reactance part. Since we have 1.5 minus J2 ohms, this value has to be taken from the lower part of my Smith chart. So how do I trace the value? The first point is 1.5. I have to check where my 1.5 lies. So here if you see I have my 1.4, here it is 1.6 and in between value is 1.5. I have to trace this value. I am just coming down and I have to check where the 2 arc is. So here I have my arc 2. I have to trace this arc and now I have a point where this 1.5 and 2 meets up. So this point is marked as 1.5 minus J2, which is my normalized impedance value. So the first step is to find out the normalized impedance and plot that value in the given chart. Next, we have to draw the SWR circle. So how do I draw that SWR circle? The normalized impedance value is plotted as A. Now I have to consider this O as center and OA as radius, and I have to draw a circle. When you draw that, I am getting a circle and this circle is called as the SWR circle. Next, I have to find out what is my admittance. So to calculate this admittance, I have to use this SWR circle as well as the normalized impedance point. The point that lies diametrically opposite to my normalized impedance is called as my admittance. So with the help of a scale, I will be joining this A point, this center O, and this diametrical opposite point, and then I'll be joining that diametrically opposite point is 0.24 plus j 0.35. I am joining those two lines and extending that line to the outermost point of the circle. When you see a stub, it is always placed at a distance from my receiver only. So from the receiver, when I am moving in the opposite direction, it means I am moving towards the generator. So when you see in the Smith chart, I have to check for the circle where it is marked as wavelength towards generator. In that circle only I have to calculate all the other points. Now we have calculated this normalized impedance. We have drawn the SWR circle. I have found out what my admittance point is. So by joining all my A, O and B, I am extending that line to the circle where it is marked as wavelength towards generator, and that point is marked as B dash and 0.052 lambda. If you see, you can see over here. Okay, so that point is mentioned as B dash. Why this lambda is, whenever a wave is traveling, we give them only in terms of wavelength. So whatever value that you are marking around along the circle in the Smith chart, we will have that value in terms of lambda only. Next, I have to, the point of intersection between the constant S circle and the unit circle is this one, 1 plus j 0.7. Now the next point is we have to calculate the length and position of the stub. For that I'll be considering this unit circle. So when you say this SWR circle, the circle that lies along my 1.0 is called as unit circle. This is my SWR circle and this circle is my unit circle. So I have to find out what is the point of intersection between those two circles, and I have found this is the point of intersection. I just know only the point of intersection. From that I have to find out what my real value is and what the reactance value is. So to calculate that, I have to, from this point I have to trace my real value and the imaginary value. I have this point, when I move this it is actually going towards 1.7, and here this is the real part which is 1 only. So the point of intersection is 1 plus j 1.7. Okay. Now I have to join my center O, this C point, and extend that line to the outermost circle of my Smith chart, like how we did for this admittance line. Once that is done, I have to mark what is the value of this extended line in the wavelength towards generator circle. So here if you see, the value is 0.182 lambda, and that point is given as C dash. So from that I have to calculate where I'll be placing my stub from the receiver. So the difference between these 2 points will give the location of my stub. So this is 0.052 lambda and here it is 0.12 lambda. When I find out the difference between these two, it is 0.13 lambda. By substituting the value of lambda, we know what is the frequency. From that we are calculating the value of lambda, and if we substitute, we are getting the value of S1 as 3.9 meters. So it means from the receiving point, I'll be moving 3.9 meters towards the generator and placing my stub. So next is I have to find out what is the length of my stub. For that I'll be considering this value. You have to take this C point, find out its conjugate of the imaginary point, which is 1.7. So here that point is calculated over here, minus j 1.7. With that value I am drawing another line. So the distance between the difference between these two values will give me the will give me the position of the stub. I have been moving 3 point I'll be moving for 3.2 meters to position my stub, and few other points to calculate the distance of the stub. Here I have my L where it is 0.034 lambda, and here it is 0.25 lambda. I'll be finding out the difference and getting the value of L. Hope it is clear. Now we have calculated the position and the length of the stub. Thank you. We'll discuss in the upcoming class, we'll discuss the problems for the double stub matching. Thank you once again.